This is section 5.5, and now that we know what logs are, we're going to learn about the properties of logs. And this you'll use further, if you go further in math, you'll use these properties more than once. So let's try and see what we got here. So we have log base a of 1 is equal to 0, and log base a of a is equal to 1. So those are just kind of basic ones. Log base, if you have the same base number here, that's going to be equal to a 1. And anything to the 0 power is 1, so it doesn't matter what a is. If you have two logs with the same base and you're adding them, you can rewrite it as 1 log of the product. If you have two logs with the same base and you're subtracting them, you can write it as 1 log of a quotient. And then if we have log base a of m to the r, that power can come to the front. Sometimes that's important to get the power out of that exponent spot and down on the line. So let's go through some examples. If we have, we're going to expand these. If we have log 6 over z, that's a quotient. So we know that quotient goes to subtraction if we're expanding. So it's log 6 minus log z, and that would be your answer. If we have log base 2 of 4k squared x cubed, that whole thing is a product, so that's going to go to addition. So we'll write each one as a separate piece. Log base 2 of 4 plus log base 2 of k squared plus log base 2 of x cubed. Then we'll take the powers. They'll go to the front. That's the last step for those two peoples and those two parts. And then we have this log base 2 of 4. You want to always look and see if you can simplify that. Can 2 be raised to any power and get 4? Yes. So that is equivalent to 2. So there's your final answer for that one. On this one, this is a quotient, but it also has a product up here. You want to do your quotient first. So the quotient is the top log minus the bottom log. So we got log base 5 of 25x cubed minus log base 5 of y to the 4th. Then we take care of the product. Log base 5 of 25 plus log base 5 of x cubed minus that part. Again, the powers can come to the front on these two pieces. 5 to what power could be 25? And that would be 2. So now we have this. Now the last ones that we're going to look at in the examples, they're already expanded and we're supposed to condense them. So log where we're adding becomes the log of a product, and so that is log 6. In this one we have 3 pieces. Just take 2 in order. So these 2 are being added, so that'll become a product. So we have log of 12 now minus log 2. The subtraction goes to a quotient. We have log of 12 over 2. We get log 6. Not everything will be log 6, just looks that way. So those are some examples. Now let's go look at some real problems. So these first 2 are just kind of showing you can do certain things on the calculator, and then it says which property does the calculation illustrate. So 3 log 2 and log 8. So if you go to the calculator, let's go here and clear, and if we just did 3 log 2, close and hit enter, and we get 0.903, it said round to the nearest 3 digits. And if we did log 8, same thing, we did log 8, close, enter, and we got the same thing. So 3 log 2 is the same as log of 2 cubed. Remember that power that went to the front? It could go back up here, and that's the same as log 8 because 2 cubed is 8. So this is the rule that kind of illustrates. This one, ln 63 minus ln 7, and if you do both of those, that and ln 9 in the calculator, you get the same thing. So which rule is it talking about? You've got 2 logs subtracted and that becomes a division in 63 over 7. So that's ln 9, and it's just showing you that you could do it on the calculator and see that. All right, express as the sum or difference of logs. This is a product, so it will go to addition. Log base 6 of 13 plus log base 6 of x. This tells you to put it as a difference. We should know that because it's a quotient. So that becomes log 38 minus log y. Log of x to the 5th over 2. That becomes a subtraction. So we got log of x to the 5th minus log 2. And then the power can come to the front. That'd be the only other thing to do there. In this one, there's several steps to get it. So I wouldn't even look at these choices. I would just start working it. We know this is a quotient, so we'd have ln xy to the 5th minus ln z cubed. This is a product, so we'll separate that to an addition. Then that power, that 3 comes there, 5 goes here. And so then you have your final answer. But I wouldn't try to just match. At first I would try to do the work and then put it with the right one. Expand this. Log base 7 of 49 k to the 4th x. That's a product. So we'll just separate that into addition. Log base 7 of 49 plus log base 7 of k to the 4th plus log base 7 of x. There's nothing you can do with that one. The 4 can go to the front there. 7 to some power, does it equal 49? Yes, that would be a 2. So you would have that would be your final answer. All right, in this one, we've got a division, so that'll be a subtraction, and also it's easier if you change your radical expressions to fractional exponents. So this is 4 to the 1/3. So we got log base 3 of 4 to the 1/3 minus log base 3 of s squared z. That's a product. That will become log base 3 of s squared plus log base 3 of z, but it's being subtracted, so both of them will have that minus. And then I think just that power of 2 needs to come to the front. So we should be good there. And the 1/3 came to the front right there. So do some steps, be careful. All right, rewrite as a single log. It's being added, so it becomes a product. They don't want you to actually find out what is the ln of that. They want you to write it as ln of, and go ahead and just multiply those, but don't go further than that. 10, that's an addition, so we'll do the log of a product. 36 times 1/9 is 4, so that's log 4. Number 11, write it as a single log. Start at the beginning. That becomes a product, so you've got log of 2 times 21, and then you have minus log 7, so that subtraction becomes a quotient, so log of 42 over 7 is log 6. Number 12, write it as a single log. So this is being added, so that becomes a product, and we can put these powers up. So we've got ln of x to the 4th. Okay, so I did the powers first here. And then I made this part a product, so that's one single log minus that. Now we can do a quotient. So it's ln of x to the 4th, y to the 5th over z squared. Number 13, which is the last of these type, write this as a single log. So, and it's matching, so I like to do the work over here and then find my answer. So these first two become a product. So we've got log of x to the 9th minus 7 to the 10th, x minus 3 to the 3rd, and then this was a subtraction, so it's going to go on the bottom of that. And I think the y to the 1/4 all of these are in radical form, so y to the 1/4 would be the fourth root of y. So I think this is our answer right here. Now we're going to graph. You can go right to your y equals and type, let's see. Let me bring the calculator up and we'll do. Okay, so log base 3 of x. The easiest way, if you have that log base app or icon, if you go to math and up, we can see log base, we hit enter, and your base is 3, and in your other box you've got your x, and we could just hit zoom 6, and we would get a graph, which is that one. Now, if you don't have that, you have to do log of the argument divided by log of the base. So you would have log x divided by log 3. And that should give you the same thing. And so it just went over my other graph because it is the other way to do that. So if you don't have this log base icon, it's log of the argument divided by log of the base. All right? You would do the same thing here. And when you do log base 6 and you put the other part in absolute value, let's do that. Okay, I'm going to clear that, and I'm going to clear this one. And let's go back up. So we'll do another math, up, hit that. And we've got base 6, and we'll go over into this box, and we'll go back to math and over to number. And the first one is ABS, which is absolute value. And inside here we'll put 4x, and we'll go out of that. And that's what we're going to hit graph on. And let's see. That's the one we got, D. So that's how to do that one. Using the change of base form, you can either do the log base icon, or you can do the log of 14 divided by the log of 5. You can do all that on your calculator. You can do 17 there. And then graphically, let's do this one, because 18, so we've got this equation. We want it to equal 0. When you're going to solve something, you want it to be equal to 0. So I moved the 5 over, and this is how I'm going to put it in the calculator. So let's go back over here, go to y equals, clear that out, and I'm going to do math and get that up there. Log base 3, and inside the box, I'm going to have x to the third, back down, plus x squared, plus 1. I'm going to go out of that and have a minus 5. All right, I'm going to hit graph. That should look like what I've got right there. Okay, so the solution to this is right here, but it's not going to solve it for me unless I put y2 to be 0. So I put that there, hit graph. Now I'm going to do second calc 5, enter, 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 and it popped to our x-intercept there, and it's 5.916. So that's the way to do that one. And I think that should get you going with the properties of logs and doing a little bit of graphing.